Hello, this is me, Prabha Nupani, and my friend Koteshwar Rao Bamala. Here we are going to do the group video presentation 7, and the topic for the group video presentation is risk assessment of additional works in railway construction investments using the Bayes network, which was written by the author Agnieszka Lesniak and Philip Janowick. And to start from the abstract, I would like to hand over to my friend Koteshwar.
Thank you, Prabha. Um, the risk assessment of additional works in railway construction investments using the BICE network. And coming to the abstract, an implementation of railway infrastructure and the need for additional work has been feedback. And the implementation of railway infrastructure construction projects, including sustainable development goals, is a complex process characterized by a significant extension of individual investment stages and a methodology and a proprietary management method for the risk of additional works in railway projects. And the risk analysis and risk assessment is presented, and the original elements of the work include risk events. And using this network, it is possible to compare different ways to reduce risk and risk mitigation of reducing the risk factors and determine a satisfactory level of effects, uh, which concluded, for example, like increased financial resources and as a result of additional works. And going on to the next slide, we have the introduction. In this, by performing an ambitious plan involves many risk analysis and the implementation of large infrastructure construction projects according to sustainable development goals. The complex process consisting of many stages, and the largest investments can take up to several years from the moment of creating the initial concept. And risk management in construction is a fairly widely discussed problem in the industry literature, and there are many proprietary approaches to risk. And the most important concepts include those of the project management institutes, and according to the provisions of the ISO standards, and can be treated as a combination of the events consequence of the related probability of its occurrence. And in view of the above, the risk is described by the function according to the risk management schemes, definitions, and key stages for the entire process. And here, the picture shows the risk management process according to ISO and the proprietary risk analysis methods, including specialized software. And the effects of emerging risks are presented as a change in the duration of the investment. And the frame and the next coming into the next slide describes about the framework model for the risk assessment method. And in this, each of the stages refers to different procedures, including to the risk assessment. And the risk assessment procedure presented in the ISO and the risk management principles and guidelines standard will be used as the baseline procedure. According to the guidelines of the standard, these consists of three successive stages, which includes risk identification, risk analysis, and risk evaluation. And the standard does not indicate precise solutions or methods, indicating only the directions of actions that should be taken to carry out a comprehensive risk assessment. And moving on to the next slide, the the image shows the stages of risk assessment and used methods for additional works in railway construction. And that could be The choice of the methods is dictated by the current state of knowledge regarding additional works in railway investments, which are used to obtain input data on the issue, and expert knowledge collected using structured or semi-structured interviews was used. And furthermore, this analysis of the results obtained will be performed using the Bayes networks, which allows modeling, assuming, and high certainty, and on the basis of metrics, which are according to the other, that can be clearly determine the level of risk and to carry out activities aimed at its mitigation. And the next slide shows the identification of the risk of additional works in railway projects, and this includes in accordance with the adopted assumptions that can be carried out by 4 points, which can be used as in the assumed risk level was presented as the arithmetic mean of the obtained expert responses. And after creating the questionnaire, the direct interviews with 5 participants, and the choice of experts was deliberate, and the research was conducted in the form of interviews, and they will be provided they used to describe the risk factors as well as a qualitative description of emerging types of additional construction works. In addition, the respondents indicated the impact of individual factors of additional works of the appearance of additional costs during the implementation of a construction of, uh, of the risk factors. And this slide shows the risk identification for additional works results, which can be used for the additional works and types of additional works, and the probability level of the occurrence was expressed in percents, and the determination of the level of probability of the consequences of additional works that can be used, that can be explained by the extension of time, increase in financial resources. This is due to the large number of all combinations which was included in the Bayes network model presented in this, and the obtained results which can be used of the occurrence of a type of additional work above 10% and were presented to an expert with the longest seniority and experience in the implementation of railway works, and who did not participate in the search, and in some cases the probability was not completely covered by the experts subjective assessments, and but after analysis this was considered justified and met with acceptance, and it was decided to use the cases to build a proposed model. And moving on to the next slide, the figure shows about the grouping of elements constituting the factors of the risk identification process. And in this, um, this can be this can be measured within the risk identification in accordance with the standard guidelines, should include the following elements, which includes the determination of risks and determination of consequences and determination of possible scenarios. And the responders were grouped according to the proposed scheme, and as a result, there were groups were obtained which were presented, and the risk group was divided into risk related to the appearance of additional works and risk related to the occurrence of individual types of individual works, and the substantial errors and incompleteness of project documentation, which the possible scenarios which can be examples like increase in the cost of construction investment and as a result of additional works, and the division of elements into groups completed the process of the risk identification. And this image shows the risk analysis Bayesian statistics and Bayes network method, and which can be these can be based on the results of the search and the factors where the probability of occurrence was most highly rated by the participants in the construction of the risk assessment model. And for additional works, it can be shows the selection of factors used to build the proposed risk assessment model, which is presented in this. And we can see in this figure like bad organization of works, such as changes in design solutions introduced by the invest during the implementation of the investment, and in the tracks and drainage works and network works like electro traction, like engineering object works and road works and railroad crossings. And moving into the next slide, the factors where the probability of occurrence was mostly highly rated by the participants in the construction of the risk assessment model. And the rest will be continued by my teammate Prabha.
Thank you, Koteshwar. So talking about the topic risk analysis, Bayesian status, and Bayes network method, my friend already explained about the factors where the probability of occurrence was most highly rated by the participants in the construction, which is as shown in the figure also. And for this, the Netica software was used for building the model, and the Bayes network is found to be most appropriate as it is based on the probability of events and new information to the model with expert knowledge or historical data. And to do the risk analysis, there are 4 stages of risk analysis, which contains creating the nodes of the bias network, giving relationships to particular nodes, assigning event probabilities, and performing calculation. And in this slide, we gonna discuss about the 4 topics. So first one is the creation of the nodes of the bias networks, which includes the consequences of the selected risk factors, possibility of the additional works, and types of additional works for creating the nodes of the bias networks. And it consists of the 9 nodes, and each of them was assigned unique events as per their node characteristics. And furthermore, the correct structures of the bias network is related to the relationship between individual nodes, and the uniqueness of the studied problem requires an additional work node. There are certain risk factors like the bad organization of the work, changes by the investors, and errors in the project documentation. The figure shows the bad organization of work and possible scenarios consequences. This figure shows that the bias network model to access the risk of the additional work, as my friend had already explained about the figure. And another topic is assigning event probabilities, which includes assigning to each event the probability of the occurrence for the correct functioning of the model. And also for this process, the bias network is known by the fact of initiating node by determining the probability level, and all other nodes which are connected mutually are described by the conditional probabilities, which are based on the chain method. And the process for the conditional probabilities is a labor intensive process. That is, there is a high risk to determine the probability of all events. So at first we need to identify the events and set the implementation amongst them. And the figure shows the table of the conditional probabilities for the additional work nodes, where we can see the errors of the project documentation, changes by the investor, bad organization of work, and their occurrence and non-occurrence. And another topic is performing calculation. So the Bayesian network is constructed on the theorem of the Thomas Bayes, binding the conditional probabilities of 2 events conditioning each others. And the theorem helps to determine the probability of all events forming the network. And the formula for the Bayes theorem of conditional probability is as shown in the diagram. And after we prepare the Bayes network, the calculation of the conditional probabilities are carried out in the Netica software, which was developed The calculation are used in the further steps of the risk assessment evaluation, which is as shown in the figure. The calculation of the probability by using the Bayes network, which shows the topics like bad organization of work, changes by the investor, errors of project documentation, additional works, track works, engineering object works, road works, network works, and extension of time, and how are they linked with each other. And another topic is the risk evaluation, building a risk assessment matrix. For this, the risk criteria for the subject should be determined first, and the risk is expressed as the product of probabilities values and the effect of events, and adapting the point values for the ranges. Here, the two different tables shows the event probability ranges and the event effect ranges, how they are varied. And another table shows the risk level ranges. For this, we take 4 risk level: low, medium, high, and very high. And the point level of values varies from 2, lowest and the rarest risk, to 50, very high and almost certain risk. And there are 4 different colors which is shown in the diagram to determine the risk assessment matrix. So if the color is blue, then it is the low risk level. If it is green, then it is medium risk level. If it is yellow, high risk level. And at last, if it is red, then it is very high level. So the application of the Bayes networks allows the use of the unique possibilities of this mathematical level in the form of analysis of selected event scenarios. And for the analysis of the event scenario analysis, the event has been modeled at the top of the either of project documentation, and also there is a need of the 100% probability of investigating the scene in the event described as faulty. And that another table shows the risk assessment of analyzed scenario. There are 2 levels of risk: low level risk, that is that ranges from 2 to 5 points, and high level risk that ranges from 11 to 29 points. And another topic is the risk mitigation proposal. So for the selection of the best risk management strategy, which includes risk avoidance, risk transfer, risk mitigation, risk acceptance, and emergency plan. The figure shows the Bayes network after reducing the likelihood of the occurrence of project documentation errors. And another table shows the risk assessment of the analyzed scenario after applying the risk mitigation method and showing the risk level. So talking about the summary and conclusion, in the research paper, we discussed about the risk assessment management, their mitigation, and the control of and building the model using the Bayes network. And also the author showed up one of the methodologies, that is Bayes network, for creating the risk management strategy with the use of the standard algorithm. And the algorithm includes risk identification, risk analysis, and risk assessment, which is mainly based on the Bayes network. And it also helps to construct the complex impact networks and a well-programmed network for implementing risk mitigation methods. And additional works on the tops of the network help to reduce the risk, its effects, and increasing in the value of financial resources. And at last, the author also suggests some ideas to implement network learning from expert opinions or historical data. And there is another topic, the author contribution, funding, and conflict of interest. In the topic author contribution, AL designed the research main idea, FJ collected the data and performed the calculation, AL and FJ analyzed the data and the obtained results and approved the final manuscript. And talking about the funding, this research paper received no external funding, and conflict of interest includes that there is no conflict of interest. So at last, I'd like to conclude our video presentation. Thank you.
Thank you.